Imagine a colossal gathering played by an unending number of stars, planets, and moons all playing together superbly. In any case, there is one explicit fragment of this orchestra that has surprised space specialists for a seriously prolonged stretch of time: exoplanets. Exoplanets are standard planets that exist outside our planetary system, hid away someplace deep in the Milky Way. You might be astonished to find that among the colossal number of cosmic objects, there are exoplanets so like Earth, so tantalizingly comparable yet puzzling that they might be our planet's heavenly twin. We jump into the interesting area of Proxima Centauri b. Proxima B, found just 4.2 light-years away. The James Webb Space Telescope JWST is disturbing our journey for an understanding of these divine secrets, a universe of possibilities. Imagine a second when your mind adventures across the enormous astronomical area of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon, we would have enough to make another land milestone on Earth, the Grand Canyon 2.0, that would extend for a huge distance. It's generally surprising that around 20% of these grand bodies have been assigned Earth-like as far as geography and air structure. That means there is a 1 in 5 chance of finding a twin of our planet, and the story doesn't end there. Close by these planets there could be another quadrillion moons, rough satellites like our moon, trapped in gravitational hit the dance floor with their parent planets. If you somehow manage to contemplate tracking down another body in space that harbors life, or could do so, the universe offers a flood of chances. The all-seeing eye, the James Webb Space Telescope. Now that we have spread out the material of admirable scale, it's time to introduce the master-skilled artist prepared to paint its complex nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central focal point displaced by flexible central focuses, beats even the most advanced optical instruments. We're not discussing any focal point. Its 6.5 m primary mirror is 2.7 times greater than Hubble's. Imagine the best detail it can separate, even in the smallest glimmer of a star, billions of light-years away, and then inspect the nuances of revolving around planets. What makes the James Webb Telescope revolutionary isn't simply its sheer power, but also its high-level technology, including advanced sensors and spectrographs. These devices can do significantly more than simply notice. They can investigate and filter the unprecedented light checked, sent, or reflected by grand objects to decipher their air conditions, harmony, density, and surprisingly mass. Going about as a space researcher, they can decide whether a planet has water, organic mixtures, or even oxygen. The James Webb Space Telescope has the ability to answer these inquiries, raising it from a simple observer to a logical virtuoso. It's not just an advance over its ancestor Hubble. It's more like a quantum jump. If Hubble's disclosures flabbergasted you, plan for a genuine event of radiant divulgences. Proxima B, our closest Earth-like neighbor. Just as we extended our look across the complicated scene of the universe, it's worth zeroing in on one explicit star in the divine show, Proxima B. Since its discovery in 2016, this perplexing planet has stuck out as a Shakespearean legend loaded up with multifaceted design and problems. Stunning stargazers and anthropologists alike, what's the deal with all the coral? First of all, Proxima B is basically in our galactic area, just 4.2 light-years from Earth. To put it in context, on the off chance that you could beat the universal speed limit and go at the speed of light, you would show up in somewhat more than 4 years, about the same amount of time it takes for your favorite program to fall into arrears. But let's dive further into why this nearness is so significant. We're examining a universe that broadens in excess of 93 billion light-year from one end to another, so finding a planet so close and thus uplifting for logical exploration is like viewing a gem in a heap the size of Mount Everest, a gem that possibly holds mysteries about existence itself. In the grand embroidery of the universe, Proxima B is a complex line offering us significant pieces of information that could redefine how we comprehend habitability and life beyond Earth. It's not simply Proxima B's nearness to Earth that excites established specialists, but also the captivating signs that this planet isn't just Earth-like but potentially Earth 2.0. Proxima B sits serenely in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor excessively cold but just right for liquid water to exist. Imagine cascades, meandering streams, massive lakes, and perhaps oceans as deep and puzzling as the Mariana Trench. However, before we begin dreaming about going on Proxima B, we should think about a couple of its characteristics. Leading a solitary day on this intriguing exoplanet endures a faltering 11 days. Imagine daybreaks that not just introduce another day but unfurl slowly, opposing, giving way to afternoon, and sunsets that wait, making brilliant hours that photographers long for. While it sounds idyllic, it also has huge implications for its climate and livability. How should human bioweapons change in accordance with the patterns of light and dark on Proxima B? Would we really need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way on this very surprising world? The fundamental patterns of life, as far as we know them, would be both tantalizingly similar and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in a riddle, testing our understanding of what makes a planet habitable. You could consider how we can gather precise and solid information about a world we've never visited. The James Webb Space Telescope delivers all its capacities like a giant Swiss Army knife. It's more than just a telescope, it's an incredible research lab in the vacuum of space. Thanks to its innovative technology, cosmologists not only notice planets but also examine them through a prism of scientific instruments that would make CSI labs look simple. Using advanced spectrographs, the Webb telescope can analyze the light produced and reflected by these far-off planets. Each element or compound in a planet's atmosphere absorbs or produces light at a specific frequency. By focusing on these patterns, researchers can perform a distant biopsy of divine bodies, determining not only atmospheric pressure and density but also the possible presence of compounds fundamental for life like water, organic carbon molecules, and even oxygen. Space science is not just cosmology, it's space criminal science. We don't sit idly by, waiting for clues to come to us. We actively search for them, exploring the molecules and atoms that make up these perplexing universes. The Webb telescope isn't just an eye in the sky, it's a highly specialized research lab, specialist and vast analyst all in one. It allows us to turn our hypothesis and theories about alien worlds into strategies to confirm or deny them, changing our understanding of what could exist beyond our blue dot. Right when you thought you had uncovered the most stunning layers of this galactic onion, the story veers off in a strange direction. Much like in any science fiction thriller, researchers using the James Webb Space Telescope caught something surprising from Proxima B, signals so astounding that it spread all throughout the academic halls and social media. Named as a potential techno signature, it was an electromagnetic emission so perplexing and complicatedly designed that it could point to the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the pinnacle of a discovery that vowed to reshape our perspective on reality. Could the signal be the historical confirmation that we are not alone in the universe? And just as quickly as it appeared, the signal disappeared without repeating, leaving behind not just a staggering silence but also a maze of unanswered questions and foaming speculations. Was it simply a transient celestial oddity, a fortuitous event of cosmic arrangement, or something else deliberate, a coded message, or even a sign of extraterrestrial intelligence? The solitary mission cast a shadow of mystery over Proxima B, igniting fierce debate and theory. Was it merely a passing anomaly, or is it part of a much larger story, more complex than we can imagine? But wait, the account of our grand investigation is unfinished. The ink has not yet dried and new chapters are still being written. This time it's not just ordinary researchers but Harvard scientists who are leading a change in perspective as we continue our search for extraterrestrial life. They are not satisfied with just exploring the signals and anomalies we've talked about so far. They are upping the ante by turning the James Webb Space Telescope into a sort of giant night vision telescope. They intend to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're looking at staggering possibilities, such as the chance of detecting artificial versions of cities glowing in the dark like brilliant spots. Imagine seeing the gleaming light emissions. It could be a city humming with the presence of an advanced human civilization emanating its glow into the immense vast oceans. As we continue to unwind the mysteries of the universe, the venture for extraterrestrial life takes on new aspects beyond the immediate interest in Proxima B. Our fantastic hunt digs deeper into the massive new regions of space. This pursuit is driven by both technological advancements and a profound curiosity about our place in the universe. Continuous leaps forward in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, signatures, and ground-based observatories have expanded our ability to identify and study these distant worlds. One especially captivating area of study is the search for potentially habitable exoplanets, focusing on those situated within the habitable zone of their parent stars. This zone is the ideal range where liquid water might exist on a planet's surface, providing conditions necessary for life to thrive. The further we go, the more we expand the reach of space exploration. Like a great detective, we scan the edges of the vast unknown universe, ready to encounter mind-blowing revelations, revealing cosmic clues that challenge our understanding of life as we know it. There's a sense of wonder that never quite fades, a persistent thrill that the universe may hold even more miraculous surprises in the great beyond, just waiting for us to unravel them. The exploration of space has become one of the most significant intellectual endeavors of our time, with humanity's curiosity propelling us further than ever before as we continue to peer into the depths of the universe with instruments like the James Webb Space Telescope. Our understanding of the cosmos is rapidly evolving, and so too is the possibility of discovering other forms of life. One of the most fascinating aspects of exoplanet exploration is the idea that we are not just discovering new worlds but also rewriting the definition of what it means for a planet to be habitable. As we look further into the universe, we begin to question whether life requires conditions exactly like Earth's, or if it could thrive under circumstances vastly different from our own. Could we find life on planets with hostile environments, planets with extreme temperatures, high radiation, or oceans of toxic chemicals? Or could life on other worlds take forms entirely alien to us, using biochemical processes that we can hardly imagine? In recent years, the discovery of extremophiles, organisms on Earth that can survive in the most extreme conditions, has reshaped our thinking about life's potential resilience, from microbes living near deep sea vents to bacteria thriving in Boiling hot springs Earth's extreophiles demonstrate that life is much more adaptable than we once thought could. These life forms, or something like them, exist in environments where we previously believed life could not. The potential for life beyond Earth now seems more plausible than ever. Moreover, the ongoing advancements in artificial intelligence and machine learning are significantly enhancing our ability to analyze data collected from distant planets. These technologies allow us to process vast amounts of data, searching for patterns that would be difficult, if not impossible, for humans to detect on their own. With the help of these tools, astronomers can now identify exoplanets with incredible precision, narrowing down the list of potential candidates for habitability. The next generation of space telescopes may bring us even closer to answering the most profound question humanity has ever asked: are we alone in the universe? The grand voyage continues. Meanwhile, the possibility of finding techno-signatures, the faint traces of advanced technology on distant worlds, has sparked new debates in the scientific community. What if we're not just looking for biological signatures, but also signs of alien civilizations? Could the patterns we detect in the light from distant exoplanets be a sign of intelligent life, or even a signal sent deliberately toward us? The recent discovery of a strange, unexplained signal from Proxima B reminded us that the universe may have more surprises in store, challenging our assumptions about the limits of possibility. If the James Webb Space Telescope, with its unparalleled sensitivity and cutting-edge technology, uncovers the faintest hint of extraterrestrial intelligence, it would be one of the most groundbreaking moments in human history. The discovery of alien life, whether microbial or intelligent, would redefine our place in the cosmos, forcing us to rethink